Hey guys, it's Mr. Sheelan here. This is going to be the walkthrough video on how to make the abbreviated Electron configurations. Okay, configurations. Cool. So this is going to be the walkthrough video on how it is that we can understand how to create Electron configurations that are a bit shortened. And by a bit, I mean considerably. It's going to replace a big chunk of what we're writing out. It does take a little bit of work, but that little bit of work actually isn't too bad. So we're going to take a peek here at how we can make abbreviated Electron configuration. So first, what I want to do is I want to go through and show you, just as an exercise, looking at the periodic table, how we can maybe figure out how it is that we're going to make these abbreviated, why we're going to do what we're going to do. So if you notice here real quick, what you'll notice here is that when we're looking at our chart here, remember our chart is arranged in the S block, P block, D block, F block here. Now this is not the same as what's on the periodic table, but it's arranged here where we're like increasing the energy level, because remember it's S, P, D, F as far as low to high energy levels are concerned. Okay, or I should say orbitals. Okay, so what I want to do is I want to look at a couple of Electron configurations. So over here we're going to look at lithium, we're going to look at sodium, and we're going to look at potassium. And over here we're going to look at neon, and then argon, and then krypton. Okay, so kind of speed things up here. So the Electron configuration for lithium is simply going to be just this. It's got, because remember we've got 3 electrons here. For sodium we have 11 electrons, and then for potassium we have 19 electrons. Okay, for neon, I guess to do these guys also, so neon we have 10 electrons. For argon we have 8. For argon we have 18. And then for krypton, we have 36. Okay, so we can do this. So to look at the Electron configuration for lithium here, it's going to be S12, 2S1. Okay, not too shabby. Sodium, 1S2, 2S2, and then 2P6. There's 10, 3S1. Cool beans. 1S2, 2S2, 2P6, 3S2, 3S2, and then 3P6, and then 4S1. Okay. So this is, again, what we're looking at here is just lithium, sodium, potassium. Now I want to take a quick peek here at neon. So neon is going to be 1S2, 2S2, 3P6, argon, 1S2, 2S2, 3P6, let's see, hold up, not 3P, but 2P6, my bad, sorry, it's 1, 2, 3 that gets me, 2P6, 3S2, 3P6, okay, just to make sure, 12, 18, and then krypton here, 1S2, 2S2, 2P6, 3S2, 3P6, 4S2, and 3D10, and then 4P6. Okay. So why I wanted to go through these is as just a mental exercise to show like where these are landing. So remember, lithium, sodium, potassium are all on the s orbital, or S block, when we're looking at this particular periodic table. So over here again, this is our S block in green, P block in orange, D block in yellow, F block here in pink. And so it makes sense that, hey, this is why they're in these particular blocks, is as we see here, the last and final orbital that we have electrons sitting in, S block, S block, S block, I should say S orbital, S orbital, S orbital. Okay. Not only that, what we should realize too is that as we are going down, we're noticing, okay, lithium 1s2, 2s1. Okay, sodium ends up 3s1. Potassium ends up 4s1. And I'll tell you that rubidium is going to end with 5s1. Okay, starting to see a little pattern going on here. Okay, and we can see virtually the same pattern here for our noble gases. So for neon, it's 2p6, 3p6, 4p6. So, and again, in the p orbital, this is where the last and final electrons are located. This is where we see our noble gases ending. So, what we can do is that we are going to basically bypass. We're going to bypass. Let's say we got some ending on 4d10, okay, or just 4d, okay, and we want to bypass writing out all the stuff right here, all this stuff. We want to bypass all of it, right? We want to bypass this whole chunk and just go straight to that 4d or something close to it, right? And the way that we can do that is that we're going to use the noble gases. We're going to use noble gases to abbreviate. Okay. Now, how are we going to do that? Well, look at it this way. Krypton, if you notice, krypton is going to have everything filled up to the whatever, or to the 4th p level. Argon is going to have everything up to the 3rd p level filled. Xenon is going to have everything to the 5th p level filled. Radon is going to have everything to the 6th p level filled. And then you have Oganesson, OG here. This guy is going to be filled all the way to the 7p6 level. Seeing what's happening here? So, let's see, that should be, yeah, it should be 8 actually. Hold up, 1, 2, 3, 4, 5, 6, 7. No, that's right, so 7. Okay, so we can use these guys to abbreviate to bypass all this stuff and then separate and then just start, basically just start from here over. Now, let's kind of show that in action then. So let's say for this abbreviated electron, let's do a really big one. So let's do platinum. Okay, not the biggest, but a hassle. So platinum has 78 electrons. Just simple plain Jane platinum has 78 electrons. So for the abbreviated electron configuration for platinum, what we're going to do is you're going to take a look at where it's located. So here's platinum. And what we're going to do is we're going to, again, bypass all of this stuff. We're bypassing all of this because remember, we're increasing the number of electrons as we go along. And we're going to bypass all of this. And the way we're going to do it is that we're going to say, well, xenon is in the period before platinum. Okay, and we're going to go all the way up, and we're going to abbreviate up to xenon, fill in the rest after that up to platinum. So we're going to, and again, it's xenon because it's the noble gas before, in the period before platinum. So we write it out like this. We're going to say xenon. Okay, xenon here. We're going to write it in brackets. Okay, and then we're going to just basically read our periodic table. So again, this is why it's important to understand periods versus family. So here's just 1, 2, 3, 4, 5, 6, 7. So platinum is going to be in the 6th period here. So naturally, the way that actually works then is then we start with 4s. Okay, or it's not 4s, my goodness, not 4s, 6s. I don't know why I thought of 4, 6s. We're going to start in 6s. Why 6s? Because we're in the 6th period. Okay, and then we can do this. We can just kind of hop, since we're here and we got to get to here. Well, 1, 2. Okay, well, that's going to fill our s orbital. Okay, and then now we're in d. Now, the d is a bit, how to put it, is not exactly clear, but we know we're going to be in d next, and this is where maybe if you're not comfortable with just trying to do this on your own, we're going to go to the 6s. Okay, let's see here. And this is where actually you've got to be a bit careful now, because it's not that we're going to, we're not going to go to D at the beginning, we're first going to go to F. Okay, so this is where this comes in. So, but we are going to start with 6s, and both the orbital, or sorry, both electrons are going to be in there. It's going to be a filled orbital. So we're going to go from 6s up here to 4f. Now, here, hold up. Something is, why am I blanking here? So there's 54. Xenon has 54. And so what we're looking for here is maybe platinum wasn't the best one to use here. Maybe it was here. Hold on. Hold on. Just double checking because my brain is saying something different. So plus 14. It's going to be 68. And it'll be plus 10. What am I missing here? Oh, plus that other 2 right there. Okay. So no, that does work out. Okay. Now, sorry, just had to make sure my bearing's straight here. Make sure I'm putting this in correctly without confusing you too much. Okay, so again, we are starting here with 6s2. Now, this is where you have to be careful. Up here, up at the 5th period, we can just go straight over to silver. We can go straight over to ruthenium. We can go over here to cadmium with no problem. If we're going down here, we've got to incorporate the f orbital first. And if you notice, we have to incorporate it first because here it goes 56 to 71. Now 56 to 57, 56 to 57 down here, go across, and then we go through here. So if you're super duper really careful with this, okay, it shouldn't be a problem. But it's not a bad idea to also just follow this. So we start with the 6s2. Again, why do we start with 6s2? Well, it's because we are platinum is going to be in the 6th period, and then we've got to go to the f orbital. The f orbital is going to be completely filled, and this is going to be 4f14. And then again, why 4f? Well, here's 6s, go through, and then we go back up to here to 4f right here, and then we go down. And then it's going to be 5d. Okay, and it's going to be 5d. And then here is where we can just do this. So we've got this orbital filled. We've gone through all these guys. Now we can just count how many d orbitals or how many electrons are going to be tossed in d orbital until we get to platinum. It's going to be 1, 2, 3, 4, 5, 6, 7, 8. And it's going to be 5d8. And then that should end our abbreviated electron configuration. Now, if you don't trust that, again, you can double check. Say like, well, xenon has 54. Okay, well, there's 2 electrons there. There's 14 electrons here, and there's 8 electrons here. So 54 plus 2 is 56, plus 14 is going to give me, plus 14 is going to give me 70, plus 8 is going to give me 78. So I have 78, after popping all this in, I have 78 electrons. Platinum has 78 electrons. Looks like this should be good to go. Okay, now this may have been a more complicated one that a bit more complicated than it should have been. So let's maybe do it a little bit simpler now. Let's do tellurium instead. Just to double 100% make sure we understand what's happening. So tellurium has 52 electrons, okay? And we're trying to make the abbreviated electron configuration. So I'm going to look here. Well, here's tellurium, okay? Tellurium is going to be in the 5th orbital. And krypton was the noble gas in the previous period. Okay, so looking over here, got krypton. I'm going to go over here. It looks like we're going to then tellurium is in the 5th period, and so we're going to definitely start with 5s2. Again, why 5s? Why is it filled? Well, it's because boom, boom. There's 1 electron will gain here, 1 electron will gain here. Now we can go straight through then. We can go straight through to the d orbital. Now, it's not going to be 5d, though. This is where we should bring this guy up. It's going to be 4d. Okay. And it'll be 4d10. Why? Well, it's going to be 4d10 because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, all filled. Cool. And then from 4d10, we're going to go to 5p, which makes sense because we're, again, in the 5th period. Okay. And we're going to go 1, 2, 3, 4, all the way to tellurium, so it should be 5p4. Okay. And then that should be out for tellurium. This should be our abbreviated electron configuration. Now, again, if you don't trust that, just add them up. It's going to be 36 plus 2 plus 10 plus 4. Okay, 4 plus 30. 4 plus 36 is going to give us 40 plus 2 and plus 10. Well, that's going to give me 42, and then plus 10 is going to give me 52. So there's 52 electrons in here. There's 52 electrons that we're accounting for here. Tellurium has 52 electrons. We should be good to go. Okay. And just one more, just in case we're still kind of meh about it. Let's do one here instead. Let's do manganese. One even simpler. Manganese has 25 electrons. Okay, 25 electrons. And we're just making an abbreviated electron configuration. So here's manganese right here. Manganese is going to be in the 4th period, but it's in the d orbital, so it's going to be in 3d instead of 4d. So here it is. The noble gas before is argon. So we're going to abbreviate using argon. Okay, it's in the 4th energy level, or sorry, the 4th period. So we're starting with 4s2 because that's going to be calcium and then potassium and calcium. And then we're going here 1, 2, 3, 4, 5. So it's going to be something d5, and here it's going to be 3d5. Why is it 3d5? Well, when we were at 4s2 right here, and we popped up to 3, we're going to pop up to 3d. So 4s to 3d, and then the 4p, 5s. Okay, so 4s, 3d, 5. Okay. Again, if we don't trust that, argon has 18. Here we've got 2. Here we've got 5. So it's going to be pretty much 7 plus 18, which is going to give us 25. There's 25 electrons shown here. Manganese has 25 electrons. This is our abbreviated electron configuration. That's what we saw here for tellurium. Here's what we saw up here for platinum. Okay, so that is easy peasy abbreviated electron configurations. If you still have questions for me, if there's something that you still did not get, make sure, that you get a hold of me and I'll help you out as best I can. If not, I'll see you guys in the next one.